All right, we're going to do a quick little introduction to Jamovi here. First thing we're going to do is open and browse to the college grad under 30.xlsx. This takes a minute to open up because it's a relatively large file. All right, and so this spun away here, and it shows up with analysis, but it's our data that actually we see first. We don't have anything in the analysis tab because we haven't done anything yet. So the first thing that we do, that we did in class the first time, is we went to the Jamovi library and we typed in Clinico, and we clicked on install the Clinico path descriptives because that gives us a few more descriptive things that we would like to do. So the first thing we're going to do is go over to explorations here and go down to table 1. And we don't want the table 1 format. We're going to do the GT summary here, so it gives me a few things that I'd like. This data set is about what college students are doing with their degrees after they graduate, and this is only the people under 30. The big data set has 180,000 observations and 100 or so variables, but I've pared it down a little bit. And so let's just, to give you an idea of what we're going to look at here, let's go ahead and use the search tool, and let's type in ND, and it's going to give us our broad group. We're going to put that in there, and then we'll put our medium group and our long group, so you can see sort of how they break down the degrees. There's science and engineering related, and then non-science, and so you see essentially social sciences and related sciences. And then when you come down here, you see that it gets into the larger group, so we could do arts and humanities and and that sort of thing. And so that's sort of the first thing we do with the data set, is look at these frequencies and counts. And so that's gives us the percentages, etc., which is kind of nice. If we change this to table 1 summary, it gives us some things like, you'll see it looks fairly similar, but the table 1 format, like if we had gender in there, you'd see that when you get to the bottom, if there's 2 groups, it leaves one out because you know what the other one is. So that is sometimes annoying, but if we go to the GT format, then when we get to the bottom, you'll see that it gives us males and females. I like this format better. I like seeing the information twice, even though I know that 100 minus 52 is 48. But that gives us this over in the exploration. Sort of the next thing we could think about doing is a cross-tabulation. So we might want to look at LF stat that we're going to do over here is going to be our grouping variable, and that's whether people are employed or not. And then we might want to look at by gender, for example. So is there any difference in employment by gender status? And we'll do the GT summary, so it gives us the full crosstab. And we look at this and we see that more females are unemployed and not in the labor force than males, and that gives us our first crosstab, and that's useful. GT summary, unlike something like Lancet, doesn't give us the chi-square values of them being different, and this one does, and it tells us that there's a statistically unlikely that's there. We can play with the various formats to see what it gives us, but it's all essentially the same Data just gives it to us differently, and it tells us how it does. The values gives us a little explanation of it, and so the nice thing about this is it lets us very quickly change to different table types, and see that there are some differences statistically in that. We could also, our unemployment by, let's see, by our N degree broad group, and we see here that see, one of the things is this is running the wrong way for us. One of the niceties of Excel, but if you get it, 80% of the people in science and engineering fields are employed, and that's just backwards, and the numbers are not helpful for us. So we would switch them and give us a sense that in the S&E fields, 90% across the board are employed and 0.1%, et cetera. And while it's telling us there's a significant difference, it just means these aren't equitably distributed. So wanting to look at that LF stat by a broader group, we can go over to frequencies and do an independent sample. And we could, again, see what this gives us. And we can come down here to cells. And one of the nice things about this format in the contingency tables, we can do row percentages or column percentages or total percentages. So if I wanted to know sort of relatively across here whether a greater percentage were employed in these, again, then I could do my column percentages, and there I go, 88. And without the rounding, we get to see a little better. 88% are employed, 4.6 are unemployed, and 6.6 are not in the labor force. We get to see the same sorts of things here, and we see that in the non-SE, the highest levels are in the related fields, the highest levels of unemployment or not in the labor force are in the related fields and in the non-SNE forces. We could play with this and do a variety of different categorical stats, but we're just getting warmed up here, and we could go ahead and give ourselves a bar plot. And stacked might be easier to see than, so this gives us a sort of a good sense of that. Now, one of the things about Jamovi that I don't like is it doesn't handle the graphs very well. The plots, and given that I'm recording here, it doesn't want to let me mess with the plots, but okay, if I can get there, I can copy, and that I'm pretty much stuck with this. I could export it to a PDF or a PNG or an SVG. Both EPS and SVG are editable. These are things I could bring into something else and edit the documents, but we don't really want to do that right now. One of the other things we did was sort of look at some of the other plotting capabilities, and that we can quickly look across a lot of groups against a continuous bicategorical, and we did a one-way ANOVA. And so we looked at our we did gender as a grouping variable, and we did earnings as a independent, and we did descriptive plots so we could come and see that the great sadness is that uh, um, that females are still earning a lot less than males are, but we might want to break that down a little further into some things that are going to help us understand why those are the reasons, what some of the background is on that, and we could go to our ANOVA here, so we could do multiple factors there, and we are still going to put our dependent variable as earnings. And then we might want the factors of gender, and then we could look at the broad group here, and then we would go to our model, and it's got the full model there, and so we do see significant differences there, but we can't really see it, and that's why we really like graphs. So we'll go to our estimated marginal means down here, and we'll put our n degree and broad group in there. That should break it out so we start to see these. That's almost what I wanted to see, but it still isn't super nice. Doesn't quite give me what I wanted, but we start to get there in seeing what those differences are, and we still see that there's a problem all the way across the board in terms of pay equality. We could throw another variable in here. To very quickly test that hypothesis that marital status matters. And all right, and then so we do see that. We probably should take the widowed out of this data set because it's creating issues for us, but that's what this exploratory data analysis lets us know, that effectively there isn't any real change as we come across. So you see how the graphing changes by changing these. We'll take it to the top. And that allows us to look at these in slightly different ways. And if we there's the claim that married men make a lot more money than unmarried men, and so we could look at that. That would be the never married would be the sixes, and we could look at the married, which would be the light blues, probably the hardest ones to see. And we'll go into the STEM fields, and we don't. We do see that. In fact, the light blues are the married, and we do see that they are males. We see that these males are here, those males are down there. So we see there is some support to that married males make more money than unmarried males. So I guess all the sociologists doing research out there aren't necessarily wrong. So this is our way of getting going in this. Again, don't worry that you don't have these things up there. We'll eventually load those. We are going to play a little bit more with this stuff on Thursday. Oh, quickly before I shut it down, go to save. So you can save your file. So this becomes an OMV file, which is a Jamovi file. So it will open quickly. Mine's in my OneDrive. So next time I need to go, it says it's right there. Yeah, I want to overwrite it. It's going to spin for a little bit. And now I'm going to shut it down.